topic, average efficiency. This topic. All right. Still, in this problem, let's make this assumption. Assume that these cases have the same probability. That's reasonable. The first n cases, they have the same probability. Okay, case 1, case 2, through case n, they should have equal probability number. Okay, that's a reasonable assumption. But regarding the last case, no match case, then we need another assumption. Okay, the index case. Now, what's the index case? The function returns a valid index value. Here we mean the function returns a valid index value. Okay, and that means 0 through n minus 1. And the minus 1 case, this is not a valid index, right? Minus 1. So that's the no match case. So we consider these two cases and their probability. The index case, let us assume the probability is P. P is a number between 0 and 1. The probability, valid probability number in this range. Then the negative case, 1 minus P. So that's the simple probability property. Okay, and this P, you can see this P can change for different problems. The P could be different. But in the real world, you may ask, how do we get this P in the real world applications, right? So in the real world, to get this P, we can do by experiments. Right? Because real world, when you do the search on a particular group of data, so you have all the data, you can do statistics on all data, so you can find some probability number. Okay, all right. So with this number now, we want to find the formula for the average case efficiency. So let's look at that formula. All right. So under the reasonable assumption, let's do some average case efficiency measure. All right. Here, when we look at the average case, we consider two subcases. So here, these two subcases. Okay, for the first subcase and the second subcase, we want to see in the first subcase, what is the average efficiency number? All right, because that will be much easier. And if we just take the ordinary average for the first subcase. 1 plus 2, the number of comparisons for all n cases. Then we take the division because there are n cases in that subcase. N cases in that subcase. So we do division by n, and after simplification, we get this number. Okay, that's the first subcase. For the second subcase, there is only one case, right? The no match, only one possibility, one case. So we do not need to take the average, or the average is the same number, n. So now we have these two average efficiency numbers for two subcases. But we need to combine these two subcases in certain way, in an appropriate way. Yeah. Here the question, what is that appropriate way? Okay, yeah. That is important. Yeah. How to make appropriate? Okay, when we combine these two subcases, what is the appropriate way? Yeah. All right. So here we need to use the probability numbers. These two probability numbers. Yeah. All right. So let's look at the combination of these two subcases. Yeah. All right. Yeah. So here for the first subcase, the probability equals P. The second subcase, probability equals 1 minus P. Now, how do we understand these two probability numbers? Okay, yeah. The probability, can we see the larger the probability, the more contribution of that subcase, the smaller the probability for each subcase, the smaller that corresponding subcase for the contribution. Yeah. So that's the simple observation. Yeah. Then when we put them together, we need to factor in their appropriate contribution percentage. Okay, we need to factor in that. Yeah. Here, that observation tells us we should do weighted average. The appropriate, what's the appropriate average? The appropriate means we should do weighted average. Weighted average, this type of average. Yeah. So what's the weighted average? We need to associate with different weights. When we combine these two average numbers, we need to associate these two numbers with appropriate weights. They are appropriate weights. These two numbers. We treat these two probability numbers as two weights when we do weighted average. Okay? All right. Yeah. Here, the answer, the final answer, the weighted average, the first number, we need to multiply its corresponding weight, that's P, probability. For the second efficiency number, we need to multiply its corresponding weight number, 1 minus P. So the final answer is this expression. Yeah. Here in this question, you can see I spent a lot of time. I try to let you understand how to find average case efficiency. What is the correct way to find average case efficiency? Here you can see you need to do a lot of work. Not like best case efficiency, worst case efficiency. Usually that's easy to find the best case efficiency, worst case efficiency. But to find average case efficiency, you need to do a lot of work in the right way. Because later, you have many chances you need to calculate weighted average for the average case efficiency. Okay, that's non-trivial. All right, yeah. Here, this is the first time we calculate overall efficiency. Yeah. that corresponds to the average case efficiency by weighted average. Yeah. All right. Yeah. Here for this formula, yeah. So if we want to really see its efficiency number, yeah, a good way is to look at its dominant term. Yeah. Last time in Part B, I mentioned that dominant term a little bit, right? I use that word, dominates. Yeah. Quadratic polynomial dominates linear polynomial. Yeah. Here, yeah. And I remember Sarah mentioned that leading term, right? Yeah, leading term. Yeah. Here, can we look at that leading term again? Yeah. We call it dominant term. We know the leading term is the dominant term. Yeah. Here, leading term, the term corresponding to n times p, and also 1/2, yeah. And here, n times this number, yeah. You need to put them together. That plus 1 can be ignored. So the leading term is big parenthesis 1 minus 1/2 p times n. That's the leading term. Okay, yeah. And we know from this leading term, we can see it's a linear function. Yeah. That's why we call this search algorithm linear search. Okay, yeah. All right, so we complete this topic, our computing problem number 2 here. Yeah, because it's a very simple problem.